Welcome back, students. Good morning. So, here is the third lecture of data structure. I hope you remember my name. I am Janis Shah, Assistant Professor at LJ College of Engineering and Technology. In our previous lecture, we studied about the algorithm analysis, and right now we are going to start with array, the first linear data structure. So, let's start. Okay. Outlines of today's lecture. We are going to learn about the array, memory representation of array, 1D array, 2D array, examples, column measure and row measure, and last topic is sparse matrix. So let's start. Now, array. I think I have already told you about array in my very first lecture. So students, can you tell me that what is array? Okay, array is a collection of homogeneous elements. Homogeneous means elements with same data type. Okay, so here it is, collection of homogeneous elements stored in a continuous memory location is known as array. Now, here elements stored in a continuous fashion, that means 10, 20, 30, 40, 50 in a memory in a continuous fashion. If the address of the first element is 1000, the second can be 1000, 1002, 1004, 1006. If only if the array is integer, because integer stores 2 bytes in the memory. Float stores 4 byte. Float occupies 4 bytes. Character occupies one byte in the memory. Okay, fine. So the array indexes starts from 0. The next one is syntax of array, data type, array name, and size. Integer a of 10. Now memory representation of array. Let's see. If I'm going to take integer a of 5, integer a of 5, and integer array of size 5. So see the example here. 10, 20, 30, 40, and 50 are the elements stored in the array. Okay, now what happened? The index of array starts from 0. Students, uh, please, if you have a note, then please note down. In our whole subject or in each and every lecture, we are going to consider array index starts from 0 if we are talking about the programs. Okay, and if you are talking about the algorithms, then for the algorithms only we take array index starts from 1. Okay, this is just for your information. I will again inform you in my next lectures. Okay, see here the array index starts from the 0. Okay, 0, 1, 2, 3, and 4. Okay, so what are the addresses? 1000, 1002, 4, 6, 8. Students, listen, the in arrays of type integer, that's why in integer each and every element occupies 2 bytes if the base address is 1000. Base address means the address of the first element of the array. What is the first element of the array? That it is a 0. Element is stored at index 0. If the array name is A, then it can be a of 0. So A of 0, the element is 10, address of A of 0 is 1000, the next can be a 1002. Okay. Now, if the array is a floating type array, then float occupies 4 bytes in the memory. The base address is 1000. Then next element can be, address of next element can be a 1004, 1008, 1012. Difference between two elements is 4 bytes because it's a floating type array. Okay. Now, base address is equal to 1000. What do you mean by the base address? Base address is nothing but is the address of the first element of the array. The first element of the array is known as a base address. Now, A of 0 is the first element. That's why address of A of 0 is 1000. How many memory occupied by this whole array? array is the size of 5. Each and every element contains 2 bytes. Total bytes 5 multiplied by 2, that means 10 bytes. If the array is of type of floating type, then it occupies 5 multiplied by 4, that means 20 bytes. Now, moving forward to the next topic, example of 1D array. The question is, calculate the address of element in single dimensional array. Okay, fine. It is very easy to calculate it. How? With the formula. The formula is given over on the screen. See, the formula is A of I is equal to BA plus I minus L star size. Star, that stands for multiplication. Multiply by size. So what is A, BA, I, L? We cannot understand it. Wait for a minute. I'll explain you. First, I. A of 2, A of 3, A of 4. 2, 3 and 4 are the indexes of the array. I stands for the index, which address going to be calculated by you. The next one is BA. BA stands for Bachelor of Arts. No, it's base address. Okay, fine. Next one is lower bound. L stands for lower bound of array. And size is equal to size of one element in array. Listen, if array is type of integer, then size is 2 bytes, float size is 4 bytes, character size is 1 byte. Okay, keep it in your mind. Now, total number of element in array is equal to u minus l plus 1. Just write it down in your notes, u minus l plus 1. So what do you mean by the u? U is the upper bound of array. Upper bound of array. L is a lower bound of array. Okay. So upper bound, lower bound, what is it? I'll explain you in this example. Okay. First check the example. Calculate the address of m of minus 3 if the given array is m of 9 with base address 1050 and array is integer type of array. Fine. It's fine. I think there is a little bit mistake over here. The m of minus 3, please do not consider it as a m of minus 3. Consider it as a of 6. We want to find out the address of a of 6. Okay. So here I is equal to 6. Size of one element is equal to 2. How we are going to find it? Because the array is a type of integer array. So size of array is 2. Now, lower bound of array is 0. So how can we calculate the lower bound of array is 0? See, here the array size is 9. 9 size, a of 9. That's why the index starts from 0. 0, 1, 2, 3, 4, 5, 6 up to 8. Okay. That means if array is a of 9, then index starts from 0 to 8. So what is the lower bound? 0. The first index is known as lower bound of array. 0 is the lower bound. Now BA. BA stands for base address. Now put the formula. A of I is equal to BA plus I minus L multiply by size. I is 6 because we want to find the address of A of 6. Okay. Is equal to base address 1050. Base address is 1050. Please read the question very carefully. The base address is already given 1050. I is 6. Please do not consider this. M of minus 3. No, it is A of 6. We will need to find the address A of 6. So I is equal to 6. Lower bound is 0. Size of each and every element is 2. Why? Because it is an integer type of array. Okay. So the size of each and every element is 2. Now put each and every values, calculate it, the find out the answer is 1062. Now total how many number of elements are there? So you can easily say it because array is a of 9. How many elements are? 9. But if we want to calculate using this formula, then upper bound of array is 8. Please watch on screen the mouse. Upper bound of array is 8. The lower bound of array is 0. Okay. So u minus l plus 1, 8 minus 0 plus 1 is equal to 9. Fine. Okay. Isn't it easy? Okay. So let's explain me the another question. calculate the address of m of minus 3 where the given array is m of minus 9 comma 7. So is it ever possible that m of minus 9 dot dot 7? What this shows, in some of programming languages, it might be possible that array index starts from the minus. So here in question they already give the range of index. Range of index is minus 9 to 7. Minus 9 to 7. In previous one, if you remember, the array index starts from 0 and the last element index is 8. So 0 to 8, 0 is a lower bound, 8 is a upper bound. Here minus 9 is a lower bound, 7 is a upper bound. Fine. Okay. So the base address is 1002. It's a floating type array, so that means size becomes 4. Calculate the total number of array and the total number of elements in the array, and also calculate the address of m of minus 3. Fine. Put the values. I is equal to minus 3. Okay. Size of elements 4 because it's a floating type array. Next, lower bound. Lower bound minus 9. Upper bound 7. Okay. So L is equal to minus 9. U is equal to 7. Base address is equal to 1002. Fine. Next, total number of elements. Total number of elements is equal to u minus l plus 1. That means 7 minus minus 9. Remember that minus 9 is equal to 1, 6, 16. How many elements are there in the array? Total 16 elements are there in the array. Next, how to calculate? First, a of I, put the formula a of I, base address plus I minus l multiplied by size. If I want to find out the m of minus 3, then I is become minus 3. Base address is 1002. Okay, I is equal to minus 3. L minus 9. Put it over here. Size 4. The answer is 1026. Okay, fine. Is it easy to solve? Please remember that in so many programming language, the array index starts from the minus. So in exam or in paper, it might be possible that they give the range of the array like minus 9 to 7, minus 2 to 3. And please do not confuse over there. Okay. Now let's moving for the next question. The next topic is ability presentation of 2D array. 2D array, how it can be defined: data type, array name, row size, column size. Okay, that means integer a 3 3, 3 rows, 3 columns. Okay, see, here is the representation of the 2D array. Row indexes, column indexes. Element 0 0 is 10, 0 1 20, 0 2 30. Okay, 1 0 40, 1 1 50, 1 2 60. Fine, wait for a minute. Now, the elements of array can be represented in two different ways. One is a row measure, second one is a column measure. In row measure, what we consider, we store element according to the row wise. Okay, we fill up the data according to the row wise. 10, 20, 30, 40, 50, 60, 70, 80, 90. But if someone told me to store data according to column measure, that means I need to fill up the data according to the column: 10, 20, 30, 40, 50, 60, 70, 80, 90, such like that. Okay, there are two different ways to store the data in the memory. One is a row measure, second one is a column measure. The first one is row measure. See, normally array is a type of 3 3, total 9 elements are there. I just took a single dimensional array such like this: 10, 20, 30, 40, 50, 60, 70, 80, 90. It occupies in memory in a sequential fashion, just like that. Now, how the indexes are there? Divided into three parts: first, second, and third. It's a row measure. That's why row wise calculation is there: 10, 20, 30, 10, 20, 30, 40, 50, 60, 40, 50, 60, 70, 80, 90, 70, 80, 90. Fine. Now, these are the element a of 0 0, a of 0 1, 0 2, 1 0, 1 1, 1 2, 2 0, 2 1, 2 2. Is it fine? Okay. Now, if their addresses are 1000, 2, 4, 6, 8, but like this in a continuous fashion. When this is possible, if the element stored in a row major form. Now, column major. In column major, see, again elements are there, but sequence of elements is little bit change over there. 10, 40, 70, 20, 50, 80, 30, 60, 90. Okay, how? Let us see. Three parts because it's a column. Elements A of 0, 0, A of 1, 0, A of 2, 0. So here the elements stored as A of 0, 0, A of 1, 0, A of 2, 0, A of 0, 1, 1, 1, 2, 1 because it stored in a column major order. Okay. So the next addresses are also in a continuous fashion. Okay, fine. The next, how the elements stored in 2D array? In a two different way. One is a row major where each and every element stored row wise. In column major, elements stored in a column wise. Okay, fine. Next, example of 2D array, row major. Fine. Please watch it carefully. Calculate the address of element in 2D array for row major. The formula is A of ij. This formula is only for the row major. A of ij base address plus size multiply with C, capital C star I minus LR plus J minus LC. Okay, the formula is A of ij is equal to base address plus size star C. C means total number of columns, I means index, row index, LR stands for lower bound of row, J stands for column index, and LC stands for lower bound of column. Okay, LC lower bound of column, UC upper bound of column. If you remember in 1D array, you are going to find total number of elements with the formula U is equal to, no, total number of elements is equal to U minus L plus 1. Same like that, here total number of column is equal to UC minus LC plus 1. Fine. Now, example, calculate the address of B68. Okay, so we have row index 6, column index 8, I6, J8. If the given array is B11, 13, that means total number of rows and total number of columns are already given over here. Okay, total number of row 11, total number of column 13. Base address is 1000. The array is floating type array. Array is a floating type array. So here elements stored in a row major order. Find out the address of B6. Okay. I is equal to 6. J is equal to 8. Base address is equal to 1000. Okay. Size is equal to 4. Given R is equal to 11. C is equal to 13. Okay, sir, how can you say that C is equal to 13? C is the thing, but C is total number of columns. So here, match it. C is 13, given R is 11. Okay. In array B11, 13, that means B11, 11 that means row range of row, lower bound is 0, upper bound is 10. Okay, got it? If 13 is the total number of column, that means lower bound is 0, then the maximum index is column is 12. So 0 to 10 for row, 0 to 12 for column. So LR and LC, lower bound of row, lower bound of column is equal to 0, upper bound of row, upper bound of column is equal to respectively 10 and 12. Okay, good. Now moving for the next topic. Next thing is we need to find the C. UC minus LC plus 1. UC is 12 minus 0 plus 1, 13. Sir, we already know that 13 is total number of column. Then why are you finding with the formula? Because the people are aware about this. Okay, so C is equal to UC minus LC plus 1. 12 minus 0 plus 1, that becomes 13. Now the next one is formula for finding the address. So A of ij is equal to base address plus size multiplied by C star I minus LR plus J minus LC. base address plus size multiplied by C star I minus LR plus J minus LC. Okay, fine. Okay, so put it each and everything. Do we have base address? Yes, it is 1000. Size 4. Why 4? Because it is a floating type array. I I stands for 6. Okay. J 8. LR 0. C 0. Okay. Put each and everything. B of 6 8 is equal to 1000 plus 4 multiplied by 13 into 6 minus 0 plus 8 minus 0. Solve this, you will get the answer 1344. So what did you get? You just finding out the address of B68 from the array B11 13. Okay. So for this lecture, we just keep it till example of 2D array row major. Okay, we have another example of 2D array in row major, but we will see it in our next lecture. Till that, if you have any query in single dimensional array or 2D array, please feel free to ask me. Thank you so much.